Hi, in this video we are going to talk about the queue abstract data type implementation, and we are going to implement it with the help of linked lists. So I'm going to have the queue as a package. I'm going to have a class node. I'm going to have a class queue. And I'm going to have the standard application.java app.java from where we are going to test our application. So the node is going to be the node as we have discussed for linked list, for stacks and so on. So the generic T, of course, it extends the bounded type parameter comparable T. I'm going to have the data itself. And of course, we have to store a reference to the next node. So the node T, next node. Okay, I'm going to have the constructor, and in the constructor, I'm going to have the data itself. So this data is equal to the data. I'm going to override the toString method. I'm just going to return this.data.toString, and I'm going to generate getters and setters, so source generate getters and setters for the data and for the next node. Ctrl+Shift+F to auto format, and let's save it. Basically that's all about the node class. We have been talking a lot about it when we were implementing linked lists and when we were implementing the stack abstract data type with linked lists. Okay, what about the queue? The queue is going to have two nodes, so I'm going to have a private node T. It's going to be the first node in the queue. Of course, we have to make it generic as well. So T extends the comparable interface for T. And then we have to make the other node T. It's going to point to the last node. So basically these are pointers. Okay, we don't have pointers in Java, but you know, this first node is going to point to the first node in the queue abstract data type, and this last node is going to point to the last node in the queue abstract data type. So as far as the public boolean isEmpty method is concerned, I'm just going to return this, that the first node is equal to null or not, because if the first node is null, it means that our queue is empty. Of course, what about the public int size? We just have to return this dot count. Okay, we have to create this count, sorry. Private integer count. Okay, then what about the enqueue method? Public void enqueue with the new data, and basically we just have to increment the counter, and that's all. Of course not, we have to create a new node for T, and it's going to be the old last node, which is equal to the this.last node. And this.last node is equal a new node with new data, and this.last node dot set next node is a null. Okay, so if the queue is empty, then we are going to have this that the first node is equal to this.last node, and else the old last node dot set next node this.last node. Okay, so what does it mean? That first we increment the size of the counter, then we are going to create a new node that's going to be the old last node, and we initialize it to be the last node. Then we are going to create a new node for the last node with the new data, and we set the next node to be pointing to a null. And we have to check whether if the queue is empty, then the first node is going to be the last node as well, And else we know that the queue is not empty, so the old last node, next node is going to be the last node itself. So this is how we are going to update the references. And as you can see, it's going to have ordo 1, so constant time complexity, very fast. So as you can see, we are going to add data to the last node, basically the end of the queue, and we are going to get the items at the beginning of the queue. It is just a matter of definition that how to define the first item and the last item of the queue. Okay, so here we are going to add these items to the end of the queue, but because we store a pointer to the first node and the last node, it is symmetric in the sense that we could add the items to the first node. We just have to manipulate the first node instead of the last node, but the code would be exactly the same. Okay, so what about the dequeue? Public T dequeue. Okay. By the way, it's going to have ordo 1 running time, so very fast. So basically every abstract data type implemented with the help of linked list is going to be very fast. Of course, not that memory efficient because we have to store lots of pointers, next nodes, first node, last node, and so on, but anyways. First I'm going to decrement the counter. And then we have data to dequeue is equal to this dot first node dot get data, then this dot first node is going to be equal to the first node dot get next node, and if is empty, which means that our queue abstract data type is empty, then this dot last node is going to be a null, and I'm just going to return the data to dequeue. So what does it mean? We know that, okay, we are keep adding items to the last node, so at the end of the queue, and we keep getting items from the first node, which means that from the beginning of the queue. And we know that the data to the queue is going to be the first node data, so that's why we get the data from the first node. The first node, we have to update the references because we are going to get rid of this node. The first node is going to be the next node, so the first node dot get next node. And if this is a null, so the isEmpty is going to return the first node. So if the first node is a null, then we are going to set the last node to be equal to a null. And anyways, we are going to return the data to dequeue. Okay, so let's see whether it's working fine or not. So I'm just going to create a main method. I'm going to create this queue with, for example, integers. It is my queue is equal to a new queue. Okay, and for example, my queue. Okay, my queue that in queue, for example, 10. I'm going to insert 100 and 1000. First, I'm going to system out println myQueue.size. And then I'm going to println the myQueue.dequeue. And I'm going to keep dequeuing the items from the queue abstract data type. And okay, for stacks, we have seen that the result will be 1000, 100, and 10. But for queues, it's going to be quite the reverse. So let's see whether it's working fine or not. Yeah, it's working fine. The size is 3. And for the queue, it has a FIFO structure. So we are going to dequeue the first item we have in-queued, which is the 10. Then the 100 and then the 1000. So it is working fine. That's all about the queue implementation. And as we can see with the help of linked lists, so storing a reference to the first node of the queue and a reference to the last node of the queue, the in-queue and the dequeue methods can be implemented in constant time complexity. So the running time will be constant time complexity. Okay, thanks for watching.